Hello and welcome to the Azure Machine Learning course. Now that we know the curriculum of the DP100 certification exam, let's go ahead and see the architecture of the Azure Machine Learning. And please don't feel intimidated by this architectural diagram. I'm going to simplify it as we go along in this lecture. So the central piece of this architecture is the workspace. We also saw that during the course curriculum, that this is one of the four main aspects of the DP100 exam. Setting up and managing the workspace covers approximately 30% of the exam. Now, at the hierarchy, this is also the top level resource. Every time you need to deal with the Azure Machine Learning resources, you have to deal with the workspace. It is also the central repository for training runs, logs, metrics, output, and so on. Now, this workspace has various artifacts, and one of them is the managed resources. They include the compute instance and the compute clusters. Compute instance is nothing but the managed cloud-based workstation. It is also optimized for machine learning tasks. It comes with the pre-configured and up-to-date ML packages, so you don't have to worry about installing everything from the scratch. Also, they are fully integrated with your workspace. Using that, you can share the notebooks and other data with other users. Alright? Then, the compute cluster is just what the name suggests. It's a cluster of various compute nodes that we can use for production-grade machine learning. We can scale up to 100 different nodes or compute instances within the cluster. Of course, it will come with some cost and also depends upon the availability. Then we also need to use a couple of linked services such as the data store and the compute target. Data store is nothing but various storage services where we store our data. And as we know, there are various data storage services such as the blob storage, file storage, SQL database, and so on. Typically, you will create one data store for every storage type and then register it with the workspace. And that's why the name linked services. They can exist on their own, but when we want to use them for machine learning purpose, we will link them to the workspace and then use them. Okay? Now, the compute target is the target machine where you are going to develop, train, and then run your experiments. This could be your local machine on which you may want to do some small training work, or it could even be another virtual machine on the cloud, or even one of the compute instances. Again, it's not owned or managed as part of the workspace, but simply linked to it. So that takes care of the computing and the linked data part. Alright? Now, as we do some machine learning stuff in this workspace, we may create various artifacts and they are known as the assets within the workspace. We may create our own specific environments with specific softwares and their versions. Then as we train our models, we may conduct various experiments and those are also the assets of the workspace. Then there will be pipelines, datasets, models which get created as the assets of this workspace. And finally, when we are done with all the experiments, we may create endpoints using which we can make predictions in the production. Great. And I hope that clears what is a workspace, what are the managed resources within it, what are the linked resources to the workspace, as well as the assets created and stored in the workspace. Now, this workspace also has some dependencies. It cannot exist without those dependencies, or I will rather say the full scope of the workspace cannot be used unless we take care of certain dependencies. So the workspace is keeping track of various resources used by it. There will be various logs, various notebooks, and the entry for these assets and so on. For that, it requires its own storage, and for that, it depends upon the Azure storage account. So this data store is for the data required for the experiments and machine learning, whereas this storage account is for the administration and the working of the workspace. I hope that is clear. Similarly, it requires a container registry when we deploy the model to production, as well as train them on certain Docker instances. Then for storing various keys and secretive and sensitive information that is required for the workspace, we use the Azure Key Vault for storing them. Then the Application Insight monitors our machine learning application and keeps a log of information such as the response time, requests made, any failure or exceptions that we have got, the load and the performance, and so on. Great, and that completes the entire architecture of the Azure Machine Learning. I could have given this in the end, but it's better to have this bird's eye view in the beginning itself so that you know and understand the bigger picture and why we need certain things and why we do certain things the way we do them. When we dealt with the Azure Machine Learning Studio, the classic version of it, we didn't have to worry about these aspects because the studio was creating a free workspace for us and it was creating all the required components. That made it very easy to use and learn. But with that, we also lose some flexibility that this modularized architecture provides. This architecture is more suitable for a productionized and enterprise-grade machine learning application, where we may use multiple data stores, multiple users. We want to scale the production environment with various compute clusters and so on. Okay? And I hope now you are absolutely clear how the Azure Machine Learning works as a conceptual and architecture level. We have also created various models during the section on Azure ML Studio Classic. And let's now implement some of those as part of the Azure Machine Learning service using Designer and various other tools. So let's go ahead and do it. Thanks for watching. Welcome back. And today let's see how we can set up the workspace for Azure Machine Learning. So let's begin by creating the Azure ML workspace. So first things first, log into your Azure portal and come to the homepage of Azure by going to the portal.azure.com. Next, click on this link of create a resource. And now, if you click on the AI plus machine learning, it may show you some of these resources. But these are featured and you may or may not see the machine learning in this list. So either you can click on see all, or you can simply search for it in this search bar as machine learning. And then select the first option that is provided over here. And that will lead us to the page which shows this resource of machine learning. Click on create. And now on this page, we are going to provide various information to create our workspace first. I have purposely kept the font a bit bigger and zoomed it to 120% so that you can see it on all devices. As you have seen during the lecture on architecture, workspace is the top level resource and we must create one first in order to use the machine learning service. So the first thing is to provide the subscription. And for me, I have selected the free trial for now. And then we need to specify under which resource group the workspace will be created. I don't have any existing resource group for now, so I'm going to click on create new. And let me provide the name of the resource group as Azure ML RG01. And then this green tick over here means the name is available and we can go ahead and click OK. Next, let's provide the workspace name as Azure ML WS01. It will show a green tick if the name can be used for the workspace. And in case you use a name that is not available, it will show the message right over here. So for the region, I'm going to keep it as East US 2. It does not make any difference for now, but sometimes when you are uploading the huge amount of data, you may want to choose the region that is closest to you for faster data transfer. All right. And now by default, it has created, or I will rather say chose to create these new storage accounts for this workspace. And they will be created under the same resource group. And if you want, you can change them to something meaningful, such as AMLWS01 storage or something like that by clicking on this create new link. For now, I'm going to keep it as it is. And same goes for the key vault and the application insight resources that it will create. Okay. And then the container registry says none. And it also has this create new link as well. But now remember, the container registry is required at the time of deployment. And that's why the default is none. And even if we choose to create it, it may get created, but not used immediately. So leave it to none for now, and we will revisit it once we actually need it. All right. So that covers the basic information, or I will say the most essential information that is required for creating an Azure ML workspace. Okay. Then next, let's click on networking. And here you will see just this option of using either the public endpoint or the private endpoint. And as you can see the description over here, the public simply means we can connect to the workspace publicly from all networks if we choose this public endpoint. And if you choose the private endpoint, it will ask you to add and create a private endpoint. So if you click on add, it will ask you to create a private endpoint and has so much of information related to networking that you will need to provide. For now, I'm just going to close this and go with the public endpoint for simplicity purpose, nothing else. So next, let's go to the advanced link. And here you will see two options of data encryption and data impact. So when we create the workspace, all the metrics and the metadata is stored in the Azure Cosmos DB. And this data is encrypted. Now, using this radio button, you can choose the Microsoft Managed Encryption, or if you have your own key in the key vault, you can use that by clicking on this Customer Managed Key. And then selecting the key from your own key vault. But for now, I'm going to keep it as the Microsoft Managed Keys. It is still pretty much secured. All right. So let's now see the data impact. Now, for various purposes, every cloud provider collects some diagnostic data. But for machine learning, we will be uploading our own data. And this data can be sensitive in nature for our business. And we may not want Microsoft to collect this information in any manner. Now, this checkbox simply does that. It tells Microsoft that the data is sensitive in nature and then restricts what information is collected by the Microsoft. Okay? And then, if you want, you can specify a few tags over here to identify the resources separately. For example, if you are going to run the experiments for different departments, then you can specify the tag as department and let's say the value as marketing, just in case you are creating this workspace for marketing. It just helps for better categorization and even for billing purposes as well. Alright? And that completes everything that is required to create your workspace for Azure Machine Learning. So simply click on Review and Create. And we have the final summary page for these options. And let's hit Create to create our first workspace. And the moment you do that, you will start seeing this information of initializing the deployment, submitting it, and then deployment in progress. It will start creating various resources required, and you can see the status right over here under the progress. So it will first create the resource group, and then the dependencies of workspace insights, key vaults, storage, and then the actual workspace will be created. It could take a few minutes to create and deploy the workspace, so I'm simply going to pause the video and come back once it is done. And once it is done, you will see a message that says your deployment is complete and this button of go to the resource. But before that, let me just click on the deployment details, and here you will see the 4 resources created. So we have the workspace with the same name as we provided, and then these 3 for the insight, key vault, and the storage. Great. So congratulations if you have been doing it with me and in case you are seeing this particular screen. And now click on this button to go to our workspace. And there you go. We have this Azure ML WS01 created over here. And this page will give you the nice overview of it. You can go through it on your own or see me in the next lecture where I'm going to explain the key options that you see here. Once again, congratulations on creating your own Azure Machine Learning workspace. See you soon and thanks for watching. Welcome back. Let's now look at some of these attributes of our workspace. Well, overview is just that, an overview. It simply provides all the basic details such as the resource group, location, storage, and so on. Apart from that, it also has the studio URL, which you can use to launch the Azure ML Studio. So basically, you can launch it from this URL or from, if you scroll down a bit, you will see this Launch Studio button, and you can launch it from here as well. You can also download the config file for this workspace, and it will be required when we want to work with this workspace using Python and on a computer that is not part of this workspace. So if we want to connect and work with this workspace from our laptop, we will need this config file. Then using this tag menu, you can add a new tag or update or delete an existing one. Then under settings, we see these 3 options over here. So even though we created the workspace using public endpoint, if we decide to add a new private endpoint to it, we can do that by clicking on this private endpoint connections. And then clicking on this plus sign that says private endpoint. Now, if you know how to configure a private endpoint for your virtual network, you can proceed to do that. But usually this task is best left to the network administrator. Then inside the properties of the settings, it again gives the entire list of properties such as the workspace ID, subscription ID, and various other resources information. Then under the locks, you can manage various locks for your workspace. The most common one that you may want to use is the delete lock. This particularly is useful when we are going for production or if you plan to use the workspace for sufficiently longer time with multiple administrators. So as long as it has the delete lock on, it will prevent the deletion of the workspace. Or if you want to make the workspace read-only, you can do that also using the read-only lock. Now, another important aspect is the access control. Using access control, you can add multiple users to work on this workspace. So you can simply click on add and then enter the role assignment or the co-admin depending upon what you want to add. And on this screen, simply choose the role of owner, contributor, or reader, or whatever you have decided based on this long list of roles. And then you can specify for which resource you want to assign the access. And finally, add their email IDs to create a role for them in this workspace. The email has to have an active Azure subscription to gain the access. Then rest of these menus are pretty much self-explanatory. We are currently in the check access where you can view various roles and accesses to those users. Then under role assignment, you can see the name and their roles. And under roles, you can see all the possible roles that a user can play for this workspace. And under deny assignments, you will see the list of blocked users. Great. So let me now come back to the overview and then click on the Launch Studio to launch the Azure Machine Learning Studio. It first loads the workspace and takes a few seconds to load it. And if you are doing it for the first time, it may even give you a nice tour of Azure ML Studio. Great. And there you have it, the new and modern Azure Machine Learning Studio. Microsoft calls the earlier Studio as a Studio Classic and this one as just Studio. But I will call Classic as basic version and this one a bit more advanced version of Azure Machine Learning. So let's now go through various aspects of this studio and start building our models in the designer. But before that, let's take a quick tour of the studio in the next lecture. Thanks for watching and enjoy your time. Welcome back. And I hope you have been able to create your workspace and also launch the studio using the Launch Studio button. And it is okay if you want to first go through one complete cycle and then create it on your own. It may help you save some cost as well, because you would keep it idle for a smaller amount of time. Anyway, let's now go through the Azure Machine Learning Studio. It's a very unique platform where we can go from no code to an exhaustive Python code. Again, you will see this workspace name of Azure ML WS01 over here at the top. If you click on it, it will provide these basic details of the workspace. And if you want to change some of the things, such as the current working directory, subscription, or even the workspace, you can do that right over here. And if you change the workspace to some other workspace, it will start taking that as the default workspace. So all your artifacts, all your assets that you will create will be in the new workspace. Great. Also, it is very neat and clean, as you can see, and it has these three main categories in this menu. The first one is of author, then you have assets, and then the manage. Author simply means the creator of the machine learning experiments and pipelines. And the studio offers us three different options as of now. You can go to the code first approach if you love coding using the built-in notebook. These notebooks are stored in the default storage space of the workspace. Remember the storage account that we created while creating the workspace? That is where all these notebooks that we will create will be stored. And these notebook servers are directly integrated into the studio. So you can always bring in the output of the notebook into the designer or even deploy them using the studio. And as you can see, it provides lots of sample notebooks and tutorials. We will go through them when we learn how to work on notebooks in the studio. Next is the designer, which is a drag and drop tool for creating the machine learning models and even deploying them. Now, when you want to create your experiment, you first create a pipeline by clicking on this plus button. And this will now open the designer interface. It is very similar to the classic version of the Azure ML Studio. And if you have gone through the earlier lectures, you should not have a problem in understanding how to create your machine learning models using designer. But there are a couple of terms that are new, or I would say they have modularized certain aspects. And what we used to call an experiment in Classic Studio is now a pipeline over here. And pipeline is nothing but the same workflow that we used to create using these modules that you see here. And an experiment here is actually a collection of multiple pipeline that we will run. We will learn that in detail when we actually create a pipeline and an experiment. Alright? Then we have the authoring using the automated ML. Now, automated or AutoML is a very interesting way of building the machine learning models. All you need to do is bring in your data and tell the AutoML what you want to do with it. Whether it is a regression that you want or classification or something else. The AutoML does all the data processing, model training, model selection, as well as the final evaluation. You simply need to provide the metric for evaluation, such as the AUC-ROC score or accuracy or any such thing, and the rest is taken care of by the AutoML. You don't have to write a single line of code or even use any of these modules from the designer. And then if you're happy with the results, you can even deploy the best model from the AutoML. And that is really interesting stuff, and we will surely see that in one of the sections in action. Great. Then we have these assets that get created as part of the authoring process. So we may create datasets, experiments, pipelines, models, and endpoints. So typically you will first create the pipeline, and the collection of multiple runs of that pipeline is nothing but the experiment, as we discussed earlier. Then the trained algorithm is nothing but the model, which we will see under the models. And finally, when we deploy the models, we will have the endpoints under this category of endpoints. So as you can see, it is a very structured and modularized way of doing machine learning work. Okay? Then we have the managed category, under which we can see the compute instance, which is nothing but the customized machine learning workstation, which has got majority of the packages and softwares that is required by our experiments. Then we have the data stores, which are nothing but the connections or pointers to the external storage of data from where we want to fetch some data. So it could be an MS SQL database or MySQL database or an external blob storage. These are typically where some external application is creating and storing the data, and now you want to pull some data from there. And that is where the data store comes into the picture by storing the connection information and making a very smooth connection to the data storage. Okay? And then, as I keep mentioning it, do not worry if you're not getting everything right now. We will go through each of these in detail as part of this course. Great. Then the last one is the data labeling over here. Now, if we are doing the image classification project and bring in thousands of images for it, then each of those images needs to be labeled. And for example, whether it is a cat or dog or a horse or whatever, we may want to label that image. And it is a significant amount of work. This data label is the central place from where we can achieve all of that. Great. And that basically covers the overview of the new Azure ML Studio, as well as various assets of this workspace that we can manage from the Azure ML Studio. And with that covered, let's now create a model using the designer. But in case you do not plan to go ahead with the next lecture immediately or want to take a break or something, then I strongly recommend you to delete this workspace before you take a break. And for that, you can simply go to the Azure portal, click on Home and click on all the resources. So here you will see the list of workspace, key vault, storage account and application insight resources. You can select all of them and click on delete if this is the only resource group or if you don't have any other resources of Azure. It will ask for the confirmation. Simply type yes if you really want to and then click on the delete. For now, I'm going to cancel it as I want to show you one more way of doing that. Here you also see this resource group name for these resources. And in case you're working on multiple resource groups and if you select all, it is possible that you may delete resources from other groups as well. So you can always click on the resource group name and then on the next screen, simply delete that resource group. It will ask you to type the resource group name and then simply click on delete to delete it. This is a much safer way of deleting the resource, but it also requires some discipline of where and how we create the resources. Great. And now I'm going to keep all my resources as I'm going to teach you how to create your pipeline using the designer. And I am super excited to show how we can bring in the data, how we can process it, run it, and deploy it. As always, it's a pleasure to teach you Azure Machine Learning. Thank you so much for joining me here and have a great time. Welcome back. And before we start working on the designer, I just want to tell you what we have covered so far as the DP100 exam is concerned. So today, from this first block of setup Azure ML Workspace, we have completed the first part of it, which is to create the Azure Machine Learning Workspace. And within that, there are 3 subtopics of creating the workspace, configuring various aspects of the workspace, and finally managing it from the studio. The overall management of the assets will get covered as we create various pipelines, experiments, datasets, and such. But for this section of the exam, we are now okay. And make sure you understand how the workspace fits in the overall machine learning architecture, and also practice the workspace creation multiple times, and you should not face any issue as such. In the next few lectures, as we import the data into the workspace and create models using Designer, we will cover the other 2 sections of managing the data objects in the Azure ML Workspace and managing the compute context or compute instance for our pipelines. And as we work on the pipelines and create models, we will also cover the first section of the second block required for the DP100 exam. So without spending much time, let's go ahead and do it. Welcome back. And now, before we start managing the data objects and create various models using Designer, let's first try to understand certain concepts of data store and the dataset, particularly in the context of Azure Machine Learning. So let's first see what is a dataset. We have used it in the Azure ML Studio Classic, and we know it is nothing but some reference to the collection of the data that is used in various experiments. But here, in the context of new Azure ML Studio, we may use the data from the dataset in our notebook script AutoML, or in designer pipelines and experiments as well. And we can bring in the data for the dataset from multiple data sources, such as from local files that we can upload, from existing data stores, from web files, such as this one where we can bring in the data from the UCI link for the adult income prediction. We can also bring the data from the open dataset, and these are Azure open datasets, and it contains some of the real life datasets from various organizations. Azure has made them available for hands-on or for practice purpose as part of the Azure open datasets. Now remember, the dataset is just the reference to the actual data. You will always have the original data stored at the source. Dataset is simply referring to it, and in some cases even creating some local storage or may even cache it. So now the web files and open datasets are pretty much clear. They are there, and we simply need to connect to them to bring in the data. But when we are uploading the local file, it won't be available as a dataset straight away. It will be first stored in some sort of Azure storage. It could be a blob or a file storage or any such storage. And similarly, there could be applications that create some data. We may want to bring in that data to our workspace apart from uploading the local files. And that is where the data stores comes into the picture. Data stores are nothing but the data connections to various storage types. And let me explain that considering the wider audience. As we know, there are various means of storing the data on Azure. It can be either using the storage account or various databases or even the analytics services such as the data lake. Then they can be further broken down into specific storage types such as blob, file storage, data lake, Azure SQL database, Azure PostgreSQL, Azure MySQL, and may have the data residing in Azure Databricks as well. There can be more types, but I have chosen these 7 because currently Azure Data Store supports these 7 directly. Now the question is, how do we bring in this data into our workspace for our machine learning tasks? Well, let's take a simple scenario. Let's say we have 3 different files in the file storage, and we want to create 3 different datasets for 3 different experiments. Now, every time we want to access these files, we will have to authenticate with that storage using some sort of a key or the SAS token. And we may even have to code that specifically. Only then the data can be accessed and made available for our workspace. Now, if you are dealing with hundreds of files from the same storage, it's too much of duplication of work. And that is where the data store helps us in creating the connection to the actual data storage. So the data store stores the connection information, and we can access the data in a secured manner once we go through the data store. And that's why I said it is nothing but a data connection, which simply stores all the connection information. So every time we need to get some data from a particular storage, all we need to do is simply go to it through the data store. Great. And I don't know why it is called as data store. Azure could have renamed it as a data connector or something like that. There is already enough data and enough storage names that we may start thinking that this is another data storage type, but actually it is just a connection. So essentially we can have multiple data stores for these storage types, and then we can create our own datasets from there. Then it does not matter whether we have hundreds of files or hundreds of tables in any of these storage types. When you work with Azure ML Studio, the classic one, you don't have to worry about all these aspects, and things become pretty easy to learn. We can focus on learning the data processing and the details of the algorithm and such things. Whereas here, due to the modularized and enterprise level approach, things become slightly detailed and a bit more complex. But as I mentioned earlier, don't you worry, I'm there to make it absolutely simple for you. So let's go ahead and load some data to our workspace. Thanks for watching, and I'm sure you are enjoying the new Azure Machine Learning Studio. Have fun! Welcome back, and now that we know what is a data store and what is a dataset, let's now create them using Azure ML Studio. So here I am in the Azure portal, and I have already created the Azure ML workspace. And if you see the details of this workspace, we have already created a storage account, but this storage account is used for the workspace artifacts, such as for storing the notebooks, configuration files, and other information required by the workspace. Also, if you go to the Azure ML Studio page and then within that the data stores, you will see 2 or maybe 3 data stores already created for us. If you have used and accessed the designer, you may see this third one as well. So we have a storage account for the workspace, and to manage the data in it, we have these data stores. They both are for the same storage account, but this storage account
can have the blob storage as well as the file store. And that's why you see these two data stores over here. Now let me click on this blob storage data store, which is also the default one. And then on the next page, you can see all the information related to this data store. So there is the name, its type, and the general information. Then if you go further down, you will see the account name, or I will rather say the storage account name used for this storage, which is the same as what was given at the time of creating the workspace. And it uses the account key as the authentication type. Let me go up a bit and click on this storage account name. And it will open the details of it. And if you click on the container, it will open the details of the blob container. And you will see the blob container name over here. You can go ahead and verify it with the one on the Azure ML Studio page. So let me go back to the storage account. And if you click on the file shares, you will see the details of the file share storage. And you can again verify the name with the default data store. Alright. Now, as a good practice, you should never try to store your business data in this workspace storage account. You should always keep it in a separate storage account because that way we can secure the one from another. I mean, even if we delete the workspace, your business data is not affected. And the reverse is also true. So let me go back to the Azure portal and then click on Home. And either you can click on the storage account link if you see it here, or simply click on the Create Resource. Search for the storage account. Select it. And then click on Create to create your own storage account. So on this page, it is going to ask for certain details. So let the subscription be free trial if you are using that. Then let me create a new resource group for the business storage and click on Create New, and let's give it a name as Azure ML RGB 01. RG for the resource group and B for business. Then let's also create a new storage account. And here, the storage account name has to be in small caps. It does not accept the uppercase letters. So let's give the name as Azure ML ST for the storage and B01. The green tick means we are okay. You can leave the rest of the things as default. Also, as our main focus is getting the data to the Azure ML workspace, I am going to leave rest of these parameters of networking, data protection, and all the others to their default values. And then simply click on Review and Create. Wait for a couple of seconds as it does some basic validations of whatever we have chosen as the parameters. And very soon you will see a message that says validation passed. And now let's go ahead and click on Create to create this resource. It's going to initialize it, submit it, and finally you will see deployment is in progress message. You may have to wait for a couple of minutes for it to finish, so I'm going to pause the video and come back once it is done. Great. So I'm back as my deployment is finished, and let me click on Go to Resource. And there you go. We have our storage account created over here. You can see all the details under the Overview tab. And if you click on the container, you will see an empty list because the blob storage is simply enabled over here and a container is yet to be created. So click on this plus container button and let's create one with the name as Azure ML STB01 blob. And we also got a green tick, so everything is okay. And hit the create button to create it now. And this should not take much time. Usually it is done in a matter of few seconds. And once it is done, click on it and you will see an empty blob container over here. And even if it is empty, that is fine. We will add some data later on. But for now, we are ready with the storage account. And let's now create a data store in our workspace, which will connect to the blob storage of this storage account. So let's go back to the Azure ML Studio. And then come to this data store page by clicking on the data store. And then click on New Data Store. And on this screen, to create a data store, let's give a name as Azure ML _DS _B01. Remember, this name can only take lowercase letters, numbers, and underscores. Now, if you try to include space or something else, it will surely give you an error. And then we need to give the data store type, and it is blob storage for us. So let's keep it as it is. And the storage account is surely part of the Azure subscription. So keep that checked. So this subscription ID is entered by default. And if you want to access from some other subscription, you can enter the full blob URL, including the account name and the container name. So let me keep it to from Azure subscription. And then next, let's give the storage account name. So if you click inside this text box, you will see these two storage accounts that we have created and their resource group names. So let's select this Azure ML STB01 that we created just now. And then click inside the blob container. We only have this one container, so select that as well. And next, for the secure access, we need to provide the authentication type, which by default is account key. You can also use the SAS token, but for now, I'm going to go ahead with the account key. And now here, we need to provide the account key for the storage account. So for that, let me go back to the Azure portal and then go to the storage account of Azure ML STB01. And if you scroll down a bit on this side, you will see the access keys under the settings menu. Click on it. And there you have the two keys for accessing the storage account. I'm simply going to copy this first one. And ideally, you should keep it a secret. But because I'm going to delete this storage as well as the workspace very soon, I'm not worried too much about it right now. So let's go back to the studio. And then simply paste the account key in this text box. Alright. And then let this option be no for now. And then hit this create button to create your data store for the Azure ML STB01 storage account. It won't take long, and if you have given all the information correctly, you will see this create success message and also this data store of Azure ML DSB01 created over here. And it also has this storage account name as Azure ML STB01. So if you have been doing it along with me, congratulations on creating your own data store from your own storage account and also successfully registering it with the workspace. And when you create a workspace from the studio, it automatically gets registered. Great. So in the next lecture, let's see how we can create the dataset using this data store. Thanks for watching and have fun. Welcome back. And now that we have created the data store, let's create a dataset that can be used by our experiment for model training and prediction. But we have only created a storage account and then linked it using the data store. We actually don't have any data in the container. So the first step is to load the data into the container. So in the Azure portal, first go to the storage account, come down a bit, and then click on this container link. Then click on this blob storage container that we created earlier. And now we can upload our data to this container. For that, you can simply click on this upload button here. And now you can simply upload a file by clicking on this icon over here. Then select the file that you want to upload. I have these files over here, and I'm simply going to upload the test1 file for now. And leave the advanced options to their default values. And simply click on upload. It will start uploading, and because it's a small file, it is uploaded very quickly. So let me close it. But this may not be the best way of storing your files, because if you have multiple files to upload and you want to store them in certain folders, then we cannot do that from here. For that, we have to go back to the storage account. And then on this screen on the left hand side, we see this option of Storage Explorer. Let me click on it. And now we have a very familiar Explorer view of the storage account. So you can see this blob container, file shares, queues, and tables. And if we expand this blob container, you will see this container that we created earlier. Click on it, and it will show the file that we have uploaded to the container. And using this Explorer, you can actually create a folder as well. For that, all we need to do is click on New Folder. And on this screen, we can now create a new virtual directory. But remember, it's just a virtual folder. So if you just create it without uploading any data, you won't see it in the list over here. So let me create a folder with the name Loan Data. Click OK. And once it is created, you have to immediately upload some data to it. So let me click on the upload again. And then on this icon here. And then select the loan approval prediction file and upload it. It should be done pretty quickly. And now that our container has some data, let's create the Azure ML dataset from the studio. So let me go there and click on the datasets, followed by this create dataset button, and choose from the data store. And on this screen, let's give some name to this dataset as loan applications. Now here, the Azure ML has two options for the dataset types. One is tabular and the other as files. Most of the time, we would be dealing with the tabular data. So tabular data is something like a CSV, TSV, or any SQL query data, which is structured in a tabular format with defined rows and columns. Files are usually the unstructured data, such as the collection of images and so on. Alright, so for our loan prediction, I'm going to select the tabular type and give some description to it if you want, but it is not mandatory, and then click on Next. Then the second step is of data store selection. So we have these data stores which are previously created. So these two are for the workspace, and we created this Azure ML DS B01 for our machine learning data. So click on it and then click on Select Data Store. And now we need to browse the file path. So click on Browse. It will first make a connection to the block container, and then it will show us all the files and folders of that container. So click on Loan Data folder and then select this loan approval prediction.csv file. If there are more than one file of the same format, you can select them as well. For now, I'm just going to click on Save. So that basically saves the path for us. Then click on Next to view the settings and preview. It will start parsing the data at this stage, and then automatically it will detect the file format and also show the data preview for us. So as you can see, it has already detected the file format as delimited, and it is delimited by comma, and the encoding as UTF-8. So that is fine because we have a comma separated file or a CSV file. So everything looks good there, but it is possible that it may or may not detect the headers. And if no header is selected over here, you will see under the data preview, our column names of loan ID, gender, and others are part of the rows, whereas the column names are column 1, 2, and so on. So for that, we can simply select Use the headers from the first file. We only have one file, so there won't be any conflict or issues as such. And now, when you see the preview, the first row of the CSV file is now treated as the column names. So all looks good, and let's now click on Next to see the schema. Great. Now under the schema, it gives you an option to select either all or only certain columns from the source data. So some sort of manual feature selection can happen right over here. And by default, it has selected all the columns from the file. But as we know, loan ID is just an ID, and it is not going to play any role in the prediction. So I'm not going to select that. And also, the gender of the applicant is not going to have any impact on the outcome of the loan application. So let me deselect that as well. Then rest of the things could be important, and let's keep them selected. So now if you scroll towards the right, you will see this data type for each of these columns. It's a very smart platform, and it automatically detects the data type. So even though we only had strings and numbers, it detected the married, self-employed, as well as the last one of loan status of type Boolean, because it has just the two outcomes of yes or no. So for now, let's keep it as it is, and then click on Next to confirm the details. So on the next screen, you will now see the summary of the dataset, such as the basic information, the data store selected, as well as the file settings. Great. So everything looks good. So let me hit the Create button to create your first dataset for the Azure Machine Learning. And it may take some time depending upon how big the dataset is, but this one should be done pretty quickly. And there you go. We have our dataset created and registered, and we can now use it for machine learning. Great. And if you have been doing it with me, congratulations on creating your very own dataset. And now creating here simply means registering as well. To unregister it, or loosely speaking to delete it from the workspace, we simply need to select it and then click on the unregister button over here. And as you can see from the message, it's only going to delete the metadata of the dataset. The original data, which is there in the storage account, will remain as it is. Great. So I don't wish to unregister it for now. So let me click on cancel. Now that covers another important topic of the DP100 exam, and that is manage the data objects in Azure Machine Learning Workspace. And within that, we have also learned how to register and maintain the data store and how to create and manage the data sets. But remember, so far we have only created the workspace. The dependencies were also created while creating the workspace, and now we have simply brought in the data into the workspace. our workspace still does not have any computing power or any compute instance or any virtual machine attached to it. And in the absence of that, we will not be able to run anything. We cannot even see the profile of the data or some summary statistics of the data because it will require some processing to be done. So in the next lecture, let's go ahead and see what are these different compute instances that we can create for our Azure Machine Learning workspace before we start creating them. Once again, thank you so much for joining me here and have a great time.
Welcome back. And now that we have created this dataset, let's visualize some basic aspects of it. So for that, simply click on the dataset. And here under the details tab, you will see various attributes of the dataset, such as its property of tabular, created by the username, data store, then the relative path from the blob container. So we have the lone data folder and then the file name over here, and also various other details. The profile simply means generation of the summary statistics if we want to use this dataset in a notebook. I will come back to that a little later. For now, if we click on consume, you can see the sample code for consuming this dataset from the notebook. Again, this will require us to use the Azure ML SDK in the Python environment. So for now, I want to move to explore. So as I mentioned, I'm not ignoring these things. It's just that they require an additional knowledge of Python and Azure ML SDK. And we are going to see that in a dedicated section where it will make more sense. Alright, and here comes the Explore tab. And here we can also preview the data. It is currently showing 11 columns and 50 rows as part of the preview. Then under the profile, we can see the summary statistics using this UI-based profile page. So for every column, we have the profile, or you can say the data distribution for the numeric columns. And for the non-numeric ones, it shows the value count. Then there is the data type, the minimum, maximum values, the total count, how many records are missing, its mean, variance, standard deviation, as well as the quartile values from 0.1 all the way up to 99.9%. Then over here, you can also see some basic charts such as value count if it is a string or boolean type of variable, and if it is a numeric one, then a histogram. And even though this Explore page provides a nice summary, you should not use that as an alternative to exploratory data analysis. You can just get some sneak peek at the data from this page. And that was one quick overview of how to visualize the data in preview and also some basic exploration of the data. And let's now go ahead and learn the compute resources of the Azure Machine Learning. Thanks for watching. Welcome back. And now we know what is a workspace, various dependencies, and we also created the data store as well as the dataset. And now for our pipelines and experiments to run, we need some computing power. And that is precisely what is provided by these compute resources. So as you can see, we have two managed resources of compute instance and compute clusters. And these two are integrated with the workspace. Then we also have the compute target resource, which is simply a linked resource. These are just different names for computers, virtual machines, or the groups of virtual machines. But they have specific purpose, and that's why we have these three different types. So let's first see what is a compute instance. Well, it's just a single virtual machine that acts as the workstation in the cloud for the data scientists. But it is not just any workstation. It is fully integrated with our workspace and comes pre-configured with all the R and Python tools and environments as well as Docker and Azure ML SDK. So basically, you don't have to install almost anything on it for a typical workflow. It has everything pre-installed and configured for you. Also, the default Azure storage that we created while creating the workspace gets mounted on this compute instance. That basically means we have access to all the data stores, notebooks, and other resources from this storage. Alright, and typically this is used as the development environment. And because it is fully integrated with the workspace, it can be used by multiple users connected to this workspace. But this instance is typically used with notebooks using Python or R. At the time of creating this video, you cannot run anything of Designer or AutoML from the instance. But we can always use this instance for simple data profiling and creating the summary information of the datasets that we have created. We can also use this for small training and inferencing during the model development and testing. Now, inferencing here in very simple words is nothing but creating the endpoints in the form of web services or microservices. So please don't get confused that this is something completely new. Great, and I hope now you are clear about the compute instance. So let's now see what is a compute cluster, which is again a managed resource and is part of the workspace. Well, apart from this fancy name, it is nothing but the group of virtual machines, mostly 2 or more VMs, which are integrated with the workspace. Now, the biggest advantage of compute cluster is it can be used with all the 3 authors. So whether we are using these notebooks on the compute instance or the designer or even AutoML, we can use the compute clusters for training and even for some limited deployment. And that's why I always prefer to use the compute clusters as the compute resources, because then we don't have to worry about whether it will support a particular author or not. Great. So that's enough for now to get an overview of the compute instance and the compute cluster. And as we go along, we will create them and also use them in our experiments very extensively. For now, let's see what is this linked resource of compute target. Now, the compute target is typically divided into remote or we can say attached compute, and then we also have the inference cluster. Again, these are just computers or virtual machines. The primary aim of the target is to train or deploy the model. So instance and clusters are primarily used for development, and then when we use them for training and deployment, they are called as compute targets. But apart from these two, we can use our local machine or any other virtual machine or even a remote server of your organization as a compute target. And as I mentioned, it is used for training and testing the deployment. We can use the compute clusters also for production batch inferencing, which loosely speaking means we can use a batch web service on the compute clusters. But if we want to do real-time predictions in production using our model, then we have to use the inference clusters. And they are nothing but the AKS clusters or Azure Kubernetes Service clusters. And they have auto-scaling features and are highly scalable for any production workload in the real-time predictions. Great. And now that is one big piece of information. But if I have to categorize this from the practical usage point of view, I will say use the compute instance if you are doing your development using notebook in a Python or R environment. Then for development using designers and AutoML, use the compute clusters. And for testing your deployment, you can use the compute clusters, or for final production deployment, use the inference clusters. Great. And I hope now you are clear, and there is absolutely no doubt about the compute instance, compute clusters, as well as the compute target in terms of what they are and how we can use them. And now, as far as the DP100 exam is concerned, we are still in the setup process, and currently we are going through this learning outcome of manage, experiment, compute contexts. Big words, but now you understand what we are dealing with here. So in the next lectures, let's first set up the compute clusters for our designer workflow. And that will be among the last lectures for the setup of the workspace process. And then we will start working on the Azure ML Designer. I hope you are enjoying learning Azure Machine Learning. Thank you so much for watching and have fun.
Welcome back. So we are done with the workspace creation, its dependencies, data store, and the datasets. And let's now create a compute resource for our workspace. Now, just a word of caution. Compute resource is among the most expensive resources. So if you think it is going to take some time for you to create your pipeline and experiment, you can watch the next few videos first. And then after you are done with the pipeline draft, or you think you are very near that, you can create these compute instances or compute clusters. So make sure you have sufficient time before you start doing these hands-ons. So let's go to the studio and create a compute cluster for the designer. And to create a compute cluster, we simply need to go to the compute page. And under the compute clusters tab, click on create. Here, you will create a virtual machine in a region of your workspace. I have recreated this workspace in WestUS, and that's why it selected it by default, and it cannot be edited. Then the type of machine we need, so a dedicated and with CPU is fine for us for now. And then we need to select the virtual machine size. Now here you have some available quota, and because we are just learning, select the one with just 2 cores and maximum RAM. So I'm going to select this standard DS11 V2. It does cost a few cents per hour of usage, but I have the credits of almost $200, so I'm not going to worry too much about it, at least for now. But still, don't go for an expensive one. Simply go for just enough, not too low on configuration and not so high as well. Then hit the next button, and then on the next screen, give a unique name here. And mind you, it can accept just the letters, digits, and the dash. So for me, I'm going to provide AML-CC for compute clusters -A001. Then by default, it has picked up the maximum number of nodes as 1 and minimum as 0. Now, what happens here is when you are not using the nodes or computers for some time, it will be scaled down to save some cost. And that's what this parameter of idle seconds before the scale down means. But it also comes with its own issues, because once it gets scaled down, when we run an experiment, it needs to be up and running. And before we can execute our experiments. And that could add some time before we run the experiment. So for that, I'm going to specify the minimum number of nodes as 1 and maximum as 1. You can even specify maximum as 2 or whatever you need. But for this experiment, I suggest you do not go for 1 and 1. Okay, and considering we are just, training. So even if you choose a combination of 0 and 1 over here, it will be okay. Just be sure that it may take a little bit more time. All right, great. And once you are okay, hit the create button to create it. And now this is one service that takes maximum amount of time compared to storage and other services. So give it a few minutes and we should have a compute cluster created after that. And you will be able to see that right here under the compute clusters tab. So while it is deploying it, let me quickly show you how to create a compute instance. So for that, click on this compute instance tab, click on create compute instance. And then on this page, it now asks for a very similar information as that of compute cluster. And just that we don't have an option of dedicated over here. Then we also have the similar selection of virtual machines with their configurations. Then you can select one of these, and because we are not going to use it immediately, I'm going to go for any of these with the least possible cost. Great. And then you can click on next. And here it will ask you to provide the compute name. So for this, I'm going to provide AML-CI-B001. Now, only if you really want to create it, hit this create button and it will start creating the compute instance for you. Okay. The compute resources of virtual machines are one of the most expensive resources, as I told you earlier as well. So if you don't plan to use it immediately and still created it, please do not forget to delete them. So while it is deploying it, we have completed one more exam objective, and that is to create a compute instance for the machine learning workspace. Great. And in the next lecture, let's start creating our pipeline using Designer. I hope you are enjoying Azure Machine Learning as much as I enjoyed teaching it to you. Once again, thank you so much for watching. Welcome back. And now before we deep dive into understanding and creating the Azure ML pipeline, let's try to understand in simple terms, what is a machine learning pipeline? Well, in simple terms, it's nothing but a workflow or series of steps. So as you know, whenever we are building a model, it goes through various steps such as data processing, building and training the model, and finally deploying it in production, as well as monitoring the performance of the model. These are all high-level steps. But within the data processing also, we have data ingestion, which simply means sourcing the data and making it available for machine learning tasks. The same data then goes through various steps of data validation, feature engineering, and finally the feature selection. We basically clean the data, normalize it, do all kinds of transformations, and finally select the features or the variables which are relevant for our predictions. Then during the model building and training phase, we train our model. We may even do cross-validation, hyperparameter tuning, and finally select the best model based on certain parameters. That follows the model deployment on some production server, building endpoints or web services to draw inferences, as well as monitoring the performance of the model for any data drift. And all of these steps may require different software, tools, and even different environments or machines. Now, if our development process is not matured enough, we may do these tasks separately or in an isolated manner. There could be manual interventions at every stage. But a good machine learning pipeline is supposed to automate all these tasks from one step to another. The pipeline makes it possible to transfer the flow seamlessly between two or more steps. And because we learned and worked with Azure ML Studio in the previous sections, we didn't feel the pain of disparate flows. But in majority of the other environments, you would find that some of these tasks are done in isolation. The Azure ML Classic Studio creates a very seamless flow of our tasks. But we were also limited in our options of data ingestion, data processing, as well as the computing power. So even though we could use the import data module for importing data from various sources, we had to make a new connection for every dataset. Then we had used the export data if we wanted to store the output of any of these steps in a separate storage account. Maybe we want to use the clean data for some other purpose in some other project. Okay? And the biggest problem is we cannot use different virtual machines for different steps. It's just one VM for the entire pipeline. Some of the algorithms may take more time to train as well as predict, and we may want to use different machines for them. But we won't be able to do that in most of the typical instances. So as you can see, the moment we bring in some complexity, the automation starts falling apart, or the majority of the tools don't support them. But in the new Azure ML Studio pipeline, that problem is very well taken care of. So we now have the data store to save all the configuration directly to the storage. And then we can use as many datasets or files from that storage. We can use it for importing the data. Also, if we want to save the output data of any of these modules in a separate storage, we can do that using the same data store. Then we can also set different compute targets for different steps. So if you want to use a machine with more memory for data processing steps, or if you want to use a higher CPU for the training purpose, or even a GPU for certain tasks, you can do that from the same pipeline inside the designer or even within your notebook. I know this could sound a bit more theoretical and can get boring beyond this point. So without spending much time on theory, let's see that in action by going to the Azure ML Designer and build our own pipeline. As always, it's a pleasure to teach you Azure Machine Learning. Thanks for watching. Welcome back. So here we are at the homepage of a new Azure Machine Learning Studio. And to create a new pipeline using Designer, all we need to do is click on the Start Now. And on this Designer page, simply click on this plus button to add or create your own pipeline. And this is how authoring a pipeline interface looks like. It's very similar to Classic Studio. So you have a canvas here where you can drag and drop your modules. You have the list of modules here. And as you can see, they have also simplified these groups, but the module names remain the same. And using this search box, we can always search for any module. Then you have the name of the pipeline, and let me change that to Loan Automation. Then below that, you can use this button to hide or show the assets library. By default, the autosave is on, and I'm going to keep it as it is. Then you have the usual save, undo, redo, copy, paste, zoom, and various other options over here. You can also see the settings for this pipeline by clicking on this icon over here for the settings. I'm going to hide it for now, and we will come back to it a little later. So first, let's get our dataset of loan applications from this asset group of dataset. Simply drag and drop it on the canvas. And because this is our first pipeline, I'm going to create it from the scratch. And it is very similar to the Classic Studio, but because we are doing it for the first time, it's better to learn the entire flow. So please bear with me on that, but it is necessary to clear how the UI for the designer works. So the moment you click on this dataset, you will see the parameters of this dataset. And here you can see the information about the dataset, such as its ID, name, type as tabular, and so on. Then at the bottom, you also see the data store name as well as the path of the source file. Then under the output, you can click on this icon over here, and it will provide the dataset visualization. And as you can see, it is very similar to what we used in the Classic Studio. You can click on any of these columns and it will provide the statistics for that column as well as some histogram right over here. This is nothing different from the Classic Studio. So let me close this. And next, just to keep it simple, I'm going to select some of the columns from this dataset. So for that, let me search for select columns and then drag and drop this select columns right below the dataset module. Then connect the output node of the loan dataset to this module. Then here we need to select the columns. So click on edit columns. And then on this screen, I'm going to choose by name. And then select the married, education, self-employed, applicant income, then loan amount term, credit history, and then finally the loan status, which is also our predicted column. All done, and click on save. Then we also have these two options of output and run settings. I will come back to that just before submitting this pipeline. First, let us complete the pipeline draft. And for that, I'm going to bring some clean missing data as well. So as you must have noticed when we visualized the dataset, there were few missing records as well. So to clean them, simply search for clean missing and then drag and drop this module of clean missing data onto the canvas. Connect the output from the select module to this clean module. Then click on edit column. Then again, we have to choose the columns on which we want to perform this cleaning operation or replacing the missing values. And just to make it quick, I'm going to add all the columns and then deselect the ones which we have not selected earlier. So deselect dependents, co-applicant income, and the property area. Also, the loan status does not have any missing values, so I'm going to exclude that also from the cleaning process. And remember, it is only for the cleaning process and not for selection. So even if we don't select it here, it will still be part of the output. Also, by mistake, if you choose a column which is not selected earlier, it will give you an error that the column is not found. Alright, so click on save. Then the other options of minimum missing value ratio or maximum missing value ratio have the same meanings as in case of Classic Studio. I'm going to leave them to their default values. Then for cleaning mode, I'm going to choose remove entire row. There is no specific reason for that. It's just that we have already covered various other options earlier. Also, it saves some time in this video also. Otherwise, I will have to provide replace by mean for numeric and then mode for string, and there will be some more cleaning operations and so on. I hope that is okay with you for now. Then the next step is to split the data into train and test. So let me search for split module or split data module and select this split data module and drag and drop it on the canvas. Again, connect the first output node of the clean missing data to the split. Then under options for split data, leave the default of split rows as it is, because that's what we are going to do. So we are going to split this dataset into rows. Then I'm going to provide this fraction of rows to 0.7, which simply means 70% of the records in this first dataset or the train dataset, and then 30% in the test dataset. Then leave the randomized split as it is. And I'm going to provide the random seed as 1, 2, 3. And then I'm going to make this stratified split as true. And that means we now need to provide the stratified column. So click on this edit column to select the column name for stratification. Then type the column name of loan status. Select it and click on save. And now we are ready to train our algorithm. So for this, I'm going to use the two-class logistic regression. So let me simply search for it as LOGI and then drag and drop the two-class logistic regression module on the canvas. Then for training this algorithm, we need a train module. So let me search for a train model. Again, drag and drop it here. Connect the train data or this first node of split data module to the train module. Also connect the logistic regression to this train model. Then click on this logistic regression module and let's leave the default values as it is, except for this random seed, which I'm going to again provide as 1, 2, 3. Then for the train model, let's edit the column to select the predicted variable. Type the predicted variable name of loan status. Save it. And let's also bring in the score model by searching for score model and then dragging it on the canvas. Connect the train model to the first node and the test data of the split to the second node of this score model. And then let's finish our last step by searching for the evaluate model. Drag it and drop it below the score model. Connect the output of the score model to the first node of the evaluate. And that's it, because we only have one model over here, so only one connection from the score to the evaluate. Now that completes drafting or authoring our first pipeline in the designer. And now for running or submitting it for the run, there are some minor additional details that I want to show you, such as the output settings and the run settings. But in the interest of time, please allow me to do those changes and run this pipeline in the next lecture. I hope you didn't have any issues while drafting this pipeline as well. So see you soon in the next lecture, and thank you so much for watching. Have fun! Welcome back, and now that our pipeline has been drafted, let's see some of the settings that can actually make this a very efficient way of running a pipeline. For that, simply click on Settings, and you will see these 4 groups here. Then out of these, the 2 most important ones are the Run settings and the Output settings. Then under the Run settings, and within that, the default compute target, you need to specify a compute target to run your pipeline. So to select a default one, you can simply click on this Select Compute Target link. And if you have already created one, you will see that under this list of existing compute resources. Then if you have not done that, you can also create one by selecting the Create New option. And to make it easy, AzureML recommends some machine, usually with 2 nodes. You can simply give a new name and create one, or you can click on this Go to link, and it will open the same page to create the cluster that we saw earlier. But as you know, we have already created these compute clusters. So while we created one of these during the Create Compute Cluster lecture, I went ahead and created another one. And very soon I will show you why I did that. So I'm going to select this cluster of D001 as the default. Click on Save. And now for our pipeline, this becomes the default compute target on which each of these modules will run. But as we discussed earlier, we want some of these modules to run on a different cluster. So let's say this cluster of D001 was good enough for data processing. But if the model training requires us to use a higher CPU machine, we should be able to configure that as well. And for that, we simply need to come down to this train model module, click on it, and under the run settings for this module, you will see the default compute target of D001. And to change it, simply click on Use Other Compute Target. Click on Select, and it will open the same window. But now here, we can also select this A001, which I have purposely created with higher core and processing power. So select that for training, save it, and then click on the score model, choose Other Compute Target, and then select the A001 for that as well. Great, and that takes care of using different machines for different tasks within the same pipeline. I mean, isn't it great to be able to do that right from the designer interface itself? And next, let's click on Settings again. And now here, under the default output settings, click on the default data store. And you will see this workspace data store selected by default. Now, in case you wonder why we require a data store over here. Well, apart from this dataset, almost all of these modules are producing some sort of an output. It could be a dataset with fewer columns for this select columns module, or it could be these 2 datasets created from the split data, or even the train and score model modules are producing some output. Our pipeline requires a way to store and access them while we are running the pipeline. And that is precisely why we use the default storage account using the default data store. But there could be a situation where more than one person is working on this data. So it's possible that someone could be doing just the data processing part, while the others could be working with different algorithms. And we may want to store this train and test data to some other storage account. In that case, you can simply click on that particular module, and in our case, it is the split data module. Then go to the output settings, and under the override option, click on Set Output Settings. And here you will see the dataset name that will be created. And then under the data store, you can either select one of the existing data stores, or you can even create a new one using this link over here. And that can be done for all the modules which do some sort of processing and produce an output. But for now, I'm going to leave the output settings to its default. And now that we have drafted our pipeline, we have chosen different compute targets, as well as know how to and where the data is stored using these output options. we are now ready to submit this run. Great. And for that, simply click on submit. And then it will ask you to select an experiment. And this pipeline will then be part of that experiment. So click on create new if you have not created earlier. And let's give it a new name as lone experiment. Great. Also, it will show you different compute targets that we have selected for different modules. So except for the train and score, we have D001 as the default. And of course the A001 for training and scoring, which is fine and very much as we wanted. So then click on submit and then it will submit the run. And once it comes back to the canvas, you will see the icon of running over here. And to view the run, you can click here and it will show you the status, submit time, duration, and various other information. And as you will see very soon, the status of these modules will change from not started to queued and then running. And when you are running it for the first time using the compute resources that we have provisioned, it is going to take significant amount of time because it needs to make the VM available, then load all the packages and then run these modules. So it is going to take that much time only when you run it for the first time on this available VMs. When you run it second or third time, it might take little less time. So give it some time and it should be fine. And in case by mistake if you have provisioned these clusters in a different region, it is possible that it may give you a data mount error. Or even sometimes there could be a glitch and it could give you this data mount error. But if that happens, then simply retry it again after some time. And if that also doesn't work, then create your data store and everything else in a different region. And hopefully then the problem will be resolved. Because I think that's the easiest option compared to trying to change its settings, etc. after the provisioning. In the meantime, you should see the status as completed for those modules which are successfully executed. But because it is going to take a few more minutes, I'm going to pause this video here and come back once it is done to visualize the result. Alright, it has finished running and now to see the results, we can simply select the evaluate model and then right click on it and click on visualize. And that should show us the evaluation result. And here you see a very familiar UI that shows various curves, including the ROC curve. Then if you scroll down a bit, you will see this confusion matrix as well as various ratios and metrics right over here. It is nearly 80% accurate, but the purpose of this lecture is not about getting the best accuracy, but in this lecture, I just wanted to show you how to create a pipeline using the designer. Also, in this lecture, we saw how to ingest and process the data, as well as how to configure the pipeline using different compute and data stores. And with that covered, you should be able to create your own pipelines and experiments in the new Azure ML Studio using the designer interface. So all the best for creating your pipeline and running it. Have fun. And in case you face any issue, please do not hesitate to write to me, either in a message or in Q&A. I will be more than happy to help you. Thanks for watching, and in the next lecture, let's see how we can create an inference pipeline and then deploy it. Have a great time.